Imagine computing is like dinner. You could build a kitchen from scratch, you lease a unit, install ovens, hire staff and security, and a bunch of other stuff. After all that time and money, you still haven't cooked a single meal because you also need to plan menus and keep the equipment running. For decades, that was normal. Companies built their own data centers before they wrote a single line of code. Back to the kitchen food example. Today, you simply open an app and order exactly what you need. There is no cleanup and no maintenance. The food is just delivered to your door. The cloud is not magic vapor. It is a network of massive industrial kitchens that are operated by providers such as AWS, Microsoft Azure, and Google Cloud. You don't own the hardware, you order the computing you need and you pay only for what you consume. So pulling this kitchen analogy apart, how does it all work? So first let's consider geography. When you click create server, where does it go? Cloud providers divide the world into regions such as London, North Virginia, and Sydney. Each region contains several availability zones, which are separate buildings full of servers. The golden rule is that everything fails eventually. If you put everything in one building and that building floods, you go dark. If you spread your workload across several zones, you stay online even when one goes down. That resilience is what we call high availability. Regions also help with data residency and latency because you can place your services close to your users and comply with local rules. Now that we have location sorted, the next question is your service level. Think of a sliding scale of responsibility. At one end, you have infrastructure as a service, which is like renting an empty commercial kitchen. You can get the raw equipment and you cook, clean, and maintain the operating system. In this scenario, you have maximum control and you accept maximum responsibility. Step up and you reach platform as a service. A staffed kitchen where the ovens are preheated. You bring the recipes, which is your code, while the platform handles the chores. And at the far end, you have software as a service, which is dining at the restaurant. You choose Gmail or Salesforce, you pick from the menu, and the chef handles the rest. Now, let's zoom in on compute, which is how your software actually runs. Begin with a physical server that behaves like an apartment block. A hypervisor splits the block into virtual machines, so each one becomes a self-contained flat with its own keys and walls. This is secure, although it is heavy. By contrast, containers are lighter. They are shipping containers that bundle your app with everything it needs so it runs the same in every environment. When the number of containers grows, you introduce Kubernetes, the port authority that keeps the cranes moving. Ask it to keep 5 copies of the web app running and it handles routing, replacement, and health checks. For short bursts, you can use serverless functions, which behave like smart sockets. Your code only runs when a trigger fires, for example when a photo is uploaded, and you pay for milliseconds rather than for idle time. Code is pointless without data, so turn to storage and databases. Start with storage. Block storage is the fast, solid-state drive that is bolted to a server, which makes it ideal for operating systems and low-latency reads. File storage is a shared network drive that several servers can use at the same time. Meanwhile, object storage is the bottomless warehouse. It stores files behind URLs and scales without practical limit, which makes it perfect for videos, logs, and backups. You can also set lifecycle rules, so older files move to cheaper tiers automatically. Now look at data engines. Relational databases, also called SQL databases, use linked tables that are designed for structured records and transactions. No SQL databases store documents or key values for flexible schemas and high-speed workloads such as leaderboards or shopping carts. Now add roads and gates with networking. Your VPC is a gated estate. Subnets are the streets, route tables are the signposts. Security groups are the bouncers on each door, and a load balancer is the roundabout that spreads the traffic. You can also place a content delivery network at the edge so copies of your content sit closer to your users. In practice, a request hits the load balancer, flows to a web server on a public street, and that server fetches data from a database that is hidden safely on a private street. Security comes next, because power without locks is an invitation. In the cloud, we follow a shared responsibility model. The provider secures the building and the hardware, while you secure identities, networks, data, and applications. In practical terms, you should treat identity and access management as your door locks. Avoid the master key and give users only the access they need. Encrypt your valuables and manage keys with a key management service. Rotate secrets and keep tested backups. In short, bake security into configuration rather than leaving it as a last-minute patch. For resilience, plan a simple disaster recovery approach with regular snapshots and a tested restore in another zone or region. Before we wrap up, take a moment on costs. Flexibility is amazing, it's wonderful, until the bill arrives. The most common surprise is egress. It is cheap to move data in, but you pay to take it out, which is like a car park that charges on exit. Keep compute close to data, add caching at the edge, and watch your transfer paths. Choose the right size of server and enable auto-scaling so you are not heating a mansion for one person. For steady workloads, you can commit to a contract to lower the price. When you can tolerate interruption, you can use spot instances to save a fortune, provided you design for the 2-minute eviction warning. This is where FinOps becomes useful. Treat cost as an operational metric that you can review every day. Tag resources and set budgets and alerts. That's how you can save costs. The cloud is a superpower. It gives a solo developer the same infrastructure as a tech giant. Use the right tools, watch the meter, and lock your doors. If this video helped, please like and subscribe.